My dear students, I am your course professor for Kinematics of Machine, and this is a design course, and this course will deal on the movement of the linkages and machineries without considering the force and torque acting on it. And this is an interesting topic in design point of view, and let's go and explore this.
This is the third subject that you are studying in the design stream of mechanical engineering under your curriculum. And this kinematics of machine is going to be a 3 credit paper, and I'm going to tell you the overview of all the chapters that we are going to see in this subject. So kinematics of machinery, as I said, we are going to study about the motions, and we are not considering the force at all. We are going to focus only on the motions. Motions is characterized by velocity, acceleration, and displacement. So I am going to tell about the glimpse of all the units that we are going to see in the entire chapter. This is the first unit. First unit is dealing about the mechanisms. Mechanisms is actually the movement of linkages. We are going to design the mechanism based on the linkages and governed by the law of mechanism. We are going to design the mechanism. We are also going to see about the basic mechanism that is in existence. And the second unit is going to focus on the velocity acceleration analysis. So when a linkages move to make a desired action, that is a constrained movement. When a linkages move with respect to the other linkages to get a constrained productive work done, the velocity and acceleration that is playing a vital part in transmitting the motion have to be analyzed in a depth in order to come to a conclusion to design the linkages for the particular mechanism. So here we are going to calculate the velocity and acceleration of the linkages and to go in depth how to go in about the design of the particular system. And in the third unit, we are going to study about the cam mechanism. The cams are designed to do a particular action, that is to open or to close or actuate a mechanism at the particular instance of time. So you can see in the first diagram, two cams are there. Two cams are actuating the opening valve at different timing based on the design criteria we choose. So based on the design criteria we choose to open or close the valve, these cams are designed in particular profile, and this profile will make the displacement of the valve with respect to the slope and the velocity and acceleration of the movement of the other linkages is with respect to the profile of the cam that is designed. So this is applied in many mechanisms, in opening and closing of the engine valves, etc. And in the next unit, this is the fourth unit, here is where we are going to study about the gears. We're going to study about the gear ratios, how the transmission of gear take place in a compound gear trains when there are multiple gears engaging to get different gear ratios, and how these speed ratios are changing. And we are also going to calculate the epicyclic gear train mechanisms. So epicyclic gears are much used nowadays because of the automatic transmission and other ways of gear transmission mechanism. So you can see the two diagrams. One is the epicyclic gear and another one is a gear transmission, where we have a lot of compound gears engaged at multiple shafts to get the particular gear ratio for the mechanism. And in this fourth unit, we are going to study the application of friction in the design of clutch and brakes. So we are going to ascertain the brake geometry and the brake mechanism and its displacement and the power, and we are going to study about its friction that is playing a basic part in making this functionality of clutch and the brakes happen. And also we make calculations for different kinds of brakes and different kinds of clutches. So this is what we are going to deal in this chapter. So all the 5 units that we are going to see are going to be very much application oriented. And in this first 3 units, we are going to use drawings a lot. That is for cams, to get the cam profile, to get the particular mechanism to be done, we have to draw the cam profile. So this is a drawing unit. And second unit is also, we have to draw the couple and the force polygon, and that is velocity and acceleration vector to obtain the angular acceleration or whatever motion related parameter that we have to obtain. So this also we are using a drawing board. So all these two, second and third unit is completely drawing oriented unit. So the first unit is going to be all the basics and mechanisms and basic mechanisms. So this is what I'm trying to say. So we will see detail in the next coming class that we are going to see. Thank you.